We have an increasing number of companies working with biosimilar mAbs, and one of their biggest challenges is that they need to match the innovator profile to the biosimilar and show comparability between the two molecules. Some of the most common questions we get is how to match in terms of charge variant. The charge variants are very closely related, and it's difficult to purify them with high resolution. And in many times the customer has to sacrifice yield in order to get the right purity.
So normally we develop a process at small scale, and after we scale it up, and we have to verify that the results obtained at the larger scale are equivalent to the ones we developed at a small scale. Common pain points that we find are derived often from the fact that we are just simply using different equipment at large scale. For example, in bioreactors, we can have different bioreactor anatomy, different steering, different sparging that can impact cell growth. On the downstream side, we have larger chromatography skids that can have larger inner tubing diameter, for example, or bulbs with larger dead volumes, and the sample is going to go through some dilution that will impact in the chromatogram we obtain at the end. So taking all of this into consideration and calculate accordingly will help solve some of the unexpected results.
mAbs are typically produced in large scales, and in the recent years we have been seeing increasing titers, which means that rather large quantities of mAbs needs to be purified. This puts a lot of pressure on the downstream processes in developing more economical processes with high productivity.